So this is going on page 58 when we're done. This is a review of exponent rules, okay? I'm reviewing these with you because I think sometimes some of you may do things and you kind of think they're right, but you might be half guessing and then you're okay with it, but you know, whatever. But y'all need to put that away because that's not what we're doing right now. That should have already been done. Yeah, put that away. Otherwise you're not paying attention. Thank you very much. Okay, so we're going to start with the product rule. If I have something that looks like this, a to the m power times a to the n power, what do you do with the exponents? Add them. So this is a to the m plus n power. Okay, we're going to do a few examples here. So example number 1, very simple. If I have x to the 5th times x to the 7th, what does that give me? X to the 12th, right? I mean, that's something that we use a ton, so that shouldn't be anything that we have issues with, hopefully. So if I have x to the negative 6th times x to the 10th, what is that going to give me? X to the 4th. Do you even have to have any knowledge of negative exponents to do that? No. Okay. All right. So then we have this third one, and we're going to go backwards here. So if I have 3 to the x plus 3 power. Okay, so we are going to undo it. Here, and I didn't show my work here because I don't think you necessarily need to, plus there wasn't room, but in between this part and this part, I could have put x equals 5 plus 7, right? And then that's what gives me 12. So if I have the 5 plus 7, I can go backwards to get to this. So if I have 3 to the x plus 3 power, this is equal to 3 to the x times 3 to the 3rd. Would you agree with that? Because if I was here and going backwards, I would make that into x plus 3. Yes? Okay, so if I have this, I need to be able to undo it to get it to here because I'm going to be able to simplify. 3 to the x is 3 to the x, but what is 3 to the 3rd? 27. So this is actually 27 times 3 to the x power. Can I now multiply 27 times 3? Absolutely not. Okay? But we need to be able to apply this product rule that you've been doing a ton of, that you understand, and I think you totally do understand it, but you need to understand that you can take it backwards as well and make sure that you can do it legally. Right? Are we all good with that? Any questions? Okay. So now let's look at the product rule. A to the m over a to the n. What do I do with those exponents? Subtract them. A to the m minus n power. So example number 1, we will do x to the 12th over x to the 5th. What does that give me? X to the 7th. It's basically backwards of number 1 over there, right? Then, our second one, if I have x to the 5th over x to the negative 1 power, what is that going to give me? X to the 6th. Again, do you have to have any knowledge of negative exponents necessarily? Nope, you just got to know the quotient rule for that one. Everybody good so far? Right? Just knocking some cobwebs off? All right, power to a power rule. A to the m power to the n power, what do we do with these two? Multiply them. This one goes haywire sometimes. We don't always get that one right. All right, so for my first one, if I have x to the 5th to the 3rd power, that's going to give me x to the what? 15. Then if I have p to the 3rd power to the 1/3 power, it's just going to be p. Do you have to have any knowledge of fractional exponents necessarily? No. And I did leave that off this page, but let's just have a little throwback here. P to the 1/3 power. What's another way to write that? Oh, I could put P to the -3 power. I mean, that would, yeah, it's the cube root. It's the cube root of P. The fractional exponents are your roots. Okay, so that's why here we have P cubed, and then we take the cube root, that's why we just get P and they undo themselves, right? And we do need to know this, and we're going to get into that some more, but right now the rest of the stuff is what we're reviewing, but it's just a little FYI because we should know that. All right, so then we have a quotient to a power rule, which is another way of saying I have a fraction that I'm taking to a power, which sometimes I ask those questions and like there's crickets, right? If I say, what is 2/3 squared? Y'all are like, I don't know. All you're doing is taking that exponent and you're applying it to the numerator and denominator. Okay? So it's not that big of a deal at all. Oh, I'm sorry. I don't know why I can't hear people knock. Thank you. Okay, yep, she's here. Thank you very much. She's your door lady. Okay. So the examples here. So first one, we're going to have x squared over y to the 3rd power. So what is that going to be? X to the 6th over y to the 3rd. Yes. All right. So for the second one, what if I have x over 2 to the 5th power? X to the 5th, right, over what? 32. And because I used as an example, let's go ahead and do a third example here. As I said, what if we had 2/3 squared? That is not as difficult as we think it is, just because I know you see a fraction and you're like, oh God, I hate fractions. You got to stop saying that to yourself. What is 2/3 squared? 4/9. Okay, see how easy that is? Way easier than squaring decimals. Okay. We all good so far? Yes? Okay. So let's look at this product to a power rule. Let's talk about what it is and what it isn't. Product to a power. The A and B are being multiplied. Here's what this is not, and what so many of you always try to do. This is not A plus B to the M power. That you treat totally differently. It does not work this way. So you might want to write that down and X it out, just like I did, because if there is addition or subtraction between the A and the B, what we're about to do is not legal. Okay, that is so important that you understand that. I would be happier with you saying, I don't know what I'm supposed to do with this, but I know it's not A to the M plus B to the M, than you trying to just make up math, okay? Because you at least need to know you don't get to distribute that M. But when it's multiplication, you do. So this is A to the M times B to the M. Here, I'd have to multiply two binomials. I get a trinomial. If you distribute it, you end up in math jail. So we don't want to do that. Okay, so let's look at these examples then. So for the first one, we will do x squared times y to the 3rd power. So it's just power to a power, just like we had done before, but it's a product. So this is x to the 6th, y to the 3rd. And I think for the most part, y'all do understand this rule. You just sometimes try to apply it where you can't. And that's more the problem, I think. And then second one, we'll do 3x to the 4th to the 3rd power. So is that 3x to the 12th? No, because you got to cube the 3 as well, right? So what is 3 cubed? 27. X to the 12th. So an additional little example here. Let's say we have 3 times the square root of 5. Well, yeah, that's fine. 3 times the square root of 5 squared. This works the exact same way. This is a product. This is a product to a power. So that means I get 3 squared times the square root of 5 squared, right? So that's going to give me 9 times, what's the square root of 5 squared? 5. And then my answer is 45. So do you have to write all the steps out? No, but that's what's happening mathematically. Okay? What questions you got? All right. Let's look at negative exponent. So if I have a to the negative m power, I have 1 over a to the m power. If I have 1 over a to the negative m, I get a to the m power. So what this says here, it says base to a negative power, it moves it from the numerator or from the numerator to the denominator. But another way, what the real rule is and what's really happening here is that it's the reciprocal, okay? And that's what we need to make sure that we understand. We are getting the reciprocal here. Oh, yeah, okay? So a to the negative m becomes 1 over a to the m and so forth. So if I have, let's see, let's start with this first one. We're going to do a few of these here. X to the negative 3, what does that give me? 1 over x cubed, right? And this next one, let's do 1 over x to the negative 4, gives me what? X to the 4th, okay? What about 1/2 to the negative 2 power? Okay, so let me ask you this. Ooh. Did we all totally get 1 and 2? Yes? Okay. Number 3, does it make you hesitate a little bit? It's the same thing. But remember, what did I just say? We have to, it's actually the reciprocal. So this actually becomes, what's the reciprocal of 1/2? 2. So this actually becomes 2 squared, which is 4. Okay. This is more how it's going to be applied. This is like the straight up rule, which totally made sense to y'all, right? When we're also just modeling it up here. But this is more how we see it when we apply it. So let's look at another one then. What if I have 3 to the negative 2 power? What's that going to be? 1 over 9. Because this becomes 1 over 3 squared, and that's where 1/9 comes from. Now, you don't have to write these middle steps right here. That's totally fine. I just want to make sure you understand what's happening. You can go straight from here to here, and that's fine. But okay, what questions you got? This is, the 3 and 4 is more how the application of what you're going to see, what we got to make sure we understand. Okay, everybody good with that? All right. Then 0 exponent. A to the 0 power is what? 1. So if I have 5x to the 0 power, like this, is my answer 5 or is it 1? Okay, so if we first, which again, we wouldn't necessarily have to write all this in between, but sometimes you need to make things make sense to you. I can do the power to the product of the power to a product rule. This would be 5 to the 0 times x to the 0. What's 5 to the 0? 1. X to the 0 is 1. That's where you get 1 from. So since the whole thing is to the 0 power, it makes it 1. Does that make sense? All right, so what if I wrote it this way? 5x to the 0 power. What's this answer? 5. Because this would be 5 times x to the 0 is 1, and it gives you 5. So do parentheses matter? Absolutely. Do they matter when you are writing work, even though you know what you mean? Yes, because sometimes y'all will write stuff like this, intending something like this with parentheses, and then you do it correctly as if there were invisible parentheses there because you know what you're writing. When you are writing that stuff for an AP test, you can't have linkage errors. Like whatever you're writing, if you say it's equal to something, it has to legit be equal to that. So you can't get sloppy with your parentheses, okay? Even though you know what you're doing in your brain. Okay, we good with that? What questions do you have? Anything? Okay, awesome. So go ahead and get that taped in. I'm going to give you your assignment, and on the back of the assignment, I even put the answers, so you don't have to get up and check them. They're right there for you. A little bit of drill and practice.